Could the key to finding life beyond Earth lie just 11 light-years away? Meet Ross 128b, a planet that has sparked excitement among scientists and astronomers alike. Orbiting the relatively quiet red dwarf star Ross 128, this Earth-sized exoplanet sits in a zone where temperatures could allow liquid water to exist, one of the key ingredients for life as we know it. Unlike many other exoplanets found around red dwarfs, Ross 128b's host star is far less active, reducing the risk of harsh stellar flares that could strip away a planet's atmosphere. This has led researchers to wonder, could Ross 128b be one of our best chances at finding another habitable world? The discovery of this intriguing exoplanet wasn't just a lucky find. Scientists used advanced observational techniques, including radial velocity measurements, to detect its presence and analyze its characteristics. What makes Ross 128b even more fascinating is its relative proximity to Earth, close enough that future telescopes might be able to directly observe its atmosphere and determine if conditions are right for life. Researchers at the SETI Institute have also taken an interest in the system, listening for potential signals that could indicate something or someone might already be there. In this video, we'll explore what makes Ross 128b so special, how astronomers uncovered its secrets, and what the future holds for studying this promising exoplanet. Could this world be a second Earth? Or does it have challenges that make life unlikely? Stick around as we take a closer look at one of the most exciting planets outside our solar system. Discovering planets beyond our solar system requires precision, patience, and the right tools. One of the most effective instruments in this search is the High-Accuracy Radial Velocity Planet Searcher, or HARPS. Attached to a telescope in Chile, HARPS specializes in detecting the slightest shifts in a star's movement, tiny wobbles caused by the gravitational pull of an orbiting planet. This technique, known as the radial velocity method, has helped astronomers find hundreds of exoplanets, including Ross 128b. The radial velocity method works by measuring the changes in a star's light spectrum. As a planet orbits, its gravitational influence causes the star to move slightly toward and away from Earth. These movements create shifts in the star's light, known as the Doppler effect, which HARPS can detect with incredible accuracy. While this method doesn't directly capture images of planets, it allows scientists to determine their mass, orbit, and even hints about their composition. In 2017, after years of careful observation, astronomers announced the discovery of Ross 128b. Nicola Astudillo de Fru, one of the researchers involved, emphasized the importance of long-term monitoring and advanced data analysis in making this breakthrough. Ross 128b's relatively calm host star made it an especially exciting find, as many red dwarf systems are too turbulent to support life-friendly conditions. This discovery marked another step forward in the search for habitable worlds, bringing us one step closer to answering one of humanity's biggest questions: are we alone? Ross 128b is remarkably similar to Earth in many ways, making it one of the most intriguing exoplanets discovered so far. With a mass approximately 1.4 times that of Earth and a size about 1.35 times larger, it falls into the category of rocky planets, worlds that are more likely to have solid surfaces rather than being gas giants like Jupiter or Neptune. This alone makes it a strong candidate for further study, as rocky planets are the only known environments capable of supporting life as we understand it. Despite its similarities to Earth, Ross 128b's orbit is vastly different. It circles its star every 9.9 days, an incredibly short year compared to our 365-day cycle. This is because it orbits Ross 128, a red dwarf star, at a distance 20 times closer than Earth is to the Sun. While that might sound extreme, red dwarfs are much smaller and cooler than our Sun, meaning a planet must be much closer to receive a similar amount of warmth. Ross 128b sits within this delicate balance, where temperatures could, in theory, allow liquid water to exist on its surface. Scientists estimate its equilibrium temperature to be between 60 and 20 degrees Celsius, depending on its atmospheric conditions. It receives only 1.38 times more radiation than Earth does from the Sun, enough to keep it warm but not necessarily hostile. Another key factor in Ross 128b's potential habitability is its likely composition. Given its size and mass, astronomers believe it is a rocky planet rather than one covered in gas or ice. If it has an atmosphere, it could further regulate surface temperatures and even shield against radiation from space. This, combined with its relatively stable star, makes Ross 128b a prime target for future telescopes that will be capable of analyzing its atmosphere in more detail. Could this be one of the best places to search for signs of life? The data so far suggests it's possible, but there's still much more to uncover. Ross 128, the star at the heart of this planetary system, is a red dwarf, a type of star that is smaller, cooler, and much dimmer than our Sun. Red dwarfs are by far the most common stars in the galaxy, making up nearly 70% of all stars in the Milky Way. However, despite their abundance, none are visible to the naked eye from Earth because of their low brightness. This faintness actually benefits astronomers searching for exoplanets, since it means that nearby planets, like Ross 128b, are not overwhelmed by the star's glare. This makes it easier to detect their presence and, in the future, analyze their atmospheres. What makes Ross 128 particularly interesting is its quiet nature. Many red dwarfs, including Proxima Centauri, the closest star to the Sun, are notorious for their intense stellar flares. These violent eruptions release powerful bursts of ultraviolet and X-ray radiation, which can strip away planetary atmospheres and make life nearly impossible. Proxima Centauri, for example, flares so frequently that its habitable zone planet, Proxima b, is constantly bombarded with radiation levels far beyond what Earth experiences. In contrast, Ross 128 is much calmer. Studies suggest that it is at least 1,000 times less active than Proxima Centauri in terms of flare frequency and intensity. This significantly increases the chances that any atmosphere on Ross 128b has remained intact over time. Scientists believe Ross 128's quiet nature may be due to its age or magnetic field characteristics. Younger red dwarfs tend to have stronger magnetic activity, leading to more frequent flares, but as they age, their magnetic fields weaken, making them more stable. Ross 128 appears to be an older star, meaning it has likely settled into a more peaceful phase of its life. If this trend holds, it could mean that older, calmer red dwarfs are the best places to search for habitable worlds. This makes Ross 128b an even more exciting target for future studies, as its environment may have been stable enough for billions of years, plenty of time for something interesting to emerge. Ross 128b sits in a location that has scientists eager to learn more, right on the edge of its star's habitable zone. The habitable zone, often called the Goldilocks zone, is the region around a star where temperatures could allow liquid water to exist on a planet's surface. While Ross 128b receives slightly more radiation than Earth, it is still within the range where, depending on its atmosphere, conditions might be just right for water to persist. Whether or not it has oceans, lakes, or even just pockets of liquid water depends largely on its atmospheric composition, which remains one of the biggest mysteries surrounding the planet. One challenge Ross 128b might face is tidal locking, a phenomenon that occurs when a planet orbits very close to its star. This means one side of the planet would always face Ross 128, bathed in constant daylight, while the other remains in eternal darkness. At first glance, this may seem like a deal-breaker for habitability, but that might not be the case. Some climate models suggest that if Ross 128b has an atmosphere capable of distributing heat, the twilight region, where day meets night, could have stable, life-friendly conditions. Additionally, deep oceans, if they exist, could help regulate temperature across the planet, preventing extreme heat on the day side and freezing conditions on the night side. The key to understanding Ross 128b's potential for life lies in its atmosphere. Future telescopes, like the James Webb Space Telescope, JWST, and the Extremely Large Telescope, ELT, may be able to analyze its atmosphere for signs of life, known as biomarkers. Scientists will be particularly interested in detecting gases, such as oxygen, methane, and carbon dioxide, molecules that, in the right balance, could hint at biological activity. However, spotting these biomarkers is extremely difficult. The signals from an exoplanet's atmosphere are faint, and distinguishing between biological sources and non-living processes is a major challenge. Still, the possibility of detecting even a hint of a habitable atmosphere keeps Ross 128b high on the list of planets to investigate. Beyond the atmosphere, the planet's geological activity could also play a role in its habitability. If Ross 128b has plate tectonics and active volcanism, it could recycle essential nutrients and gases, maintaining a stable climate over long periods. Volcanic outgassing, for example, could release greenhouse gases that help regulate temperature, preventing the planet from becoming a frozen wasteland. On Earth, volcanic activity has played a crucial role in shaping our climate, and a similar process on Ross 128b could increase the likelihood of it supporting life. To understand what conditions on Ross 128b might be like, scientists often look to extreme environments on Earth. Microorganisms known as extremophiles thrive in places once thought to be uninhabitable. Deep-sea hydrothermal vents, Antarctica's frozen lakes, and even the acidic pools of Yellowstone. If Ross 128b has similarly harsh conditions, life, if it exists, might not resemble anything we are familiar with. The search for extraterrestrial life isn't just about finding another Earth. It's about expanding our understanding of where and how life can survive. Ross 128b may not be a perfect twin of our planet, but it remains one of the most promising candidates for a world that could support life. The discovery of Ross 128b is just the beginning. Over the next few decades, astronomers will rely on powerful new telescopes to uncover more about this intriguing world, searching for clues that could indicate whether it has an atmosphere or even signs of life. One of the most promising tools in this effort is the European Southern Observatory's Extremely Large Telescope, ELT. Once completed, the ELT will be the most advanced optical and infrared telescope on Earth, with a primary mirror spanning 39 meters. This immense size will allow it to analyze the atmospheres of exoplanets like Ross 128b, searching for the chemical fingerprints of potential biomarkers such as oxygen, methane, and carbon dioxide. By breaking down light passing through the planet's atmosphere, scientists can determine whether conditions might be suitable for life. Another crucial instrument in this effort is NIRPS, the Near-Infrared Planet Searcher. As the infrared extension of HARPS, NIRPS is designed specifically to improve the study of red dwarf stars like Ross 128. Since red dwarfs emit most of their light in infrared wavelengths, NIRPS will greatly enhance the ability to detect planets, around these stars and analyze their properties with even greater precision. This will be key in refining what we know about Ross 128b's orbit, mass, and possibly its atmospheric composition. Perhaps the most anticipated tool in the search for habitable exoplanets is the James Webb Space Telescope, JWST. With its highly sensitive infrared instruments, JWST has already begun revolutionizing our understanding of distant worlds. While its primary focus is not exoplanet research, it has the capability to detect and analyze the atmospheres of some exoplanets, particularly those around nearby stars like Ross 128. If Ross 128b has an atmosphere, JWST might be able to detect broad patterns of its composition, offering the first real hints at whether the planet could support life. Beyond these telescopes, astronomers are developing even more advanced techniques to study exoplanets in the coming years. Space-based telescopes, interferometry, which combines data from multiple telescopes to create higher-resolution images, and even direct imaging could eventually allow us to see Ross 128b in unprecedented detail. The search for life beyond Earth is entering a new era, one where planets like Ross 128b will no longer be just distant dots in the sky, but worlds that we can explore, analyze, and perhaps, one day, even visit. Ross 128 has already captured the attention of SETI researchers, and for a brief moment, it seemed like it might have been home to something truly extraordinary. In 2017, astronomers detected an unusual signal coming from the direction of Ross 128. The signal, described as strange and unexpected, sparked immediate interest, with some speculating that it could be artificial in origin. However, after further analysis, scientists determined that the signal was most likely interference from geostationary satellites orbiting Earth. While it wasn't the breakthrough many had hoped for, it highlighted the importance of keeping an eye on nearby exoplanetary systems, especially those with potentially habitable worlds like Ross 128b. Despite this false alarm, Ross 128b remains a prime target for future SETI searches. Its proximity to Earth and its stable red dwarf star make it an excellent candidate for continued monitoring. Andrew Siemion, director of the SETI Research Center at the University of California, Berkeley, has emphasized the significance of such discoveries, stating, "Nearby exoplanets, especially those in habitable zones, are among the most exciting targets for SETI. If intelligent life exists elsewhere in the galaxy, planets like these are where we should be listening." The Breakthrough Listen initiative, one of the most ambitious SETI projects ever undertaken, will likely include Ross 128b in its survey of promising exoplanetary systems, scanning for signals that could indicate technological activity. The search for extraterrestrial intelligence has a long history of detecting puzzling signals, the most famous of which is the WOW signal. Detected in 1977 by a radio telescope at Ohio State University. The WOW signal was an unexplained burst of radio energy that fit many of the characteristics astronomers expected from an artificial signal. Despite repeated efforts, it was never detected again, leaving its origin a mystery. If a similar signal were ever discovered from Ross 128b, scientists would follow strict protocols, verifying the signal across multiple observatories before making any public announcement. The question of whether we are alone in the universe remains unanswered, but planets like Ross 128b give us a clear direction for where to listen next. Ross 128be stands out in the growing list of potentially habitable exoplanets, especially when compared to its more famous neighbor, Proxima Centauri b. While both planets are Earth-sized and orbit red dwarf stars, Ross 128b is considered a much better candidate for habitability. The key difference lies in their host stars. Proxima Centauri, despite being the closest star to the Sun, is extremely active, bombarding its planet with intense stellar flares and high levels of ultraviolet and X-ray radiation. This constant assault likely stripped away any atmosphere that Proxima Centauri b might have once had, making it an extremely harsh environment for life. Ross 128b, on the other hand, orbits a far quieter red dwarf. The relatively stable nature of Ross 128 means that its planet has had a much better chance of retaining an atmosphere over billions of years. This alone makes it one of the most promising worlds for further study, as a stable environment is one of the key ingredients for habitability. Compared to other well-known exoplanets, such as TRAPPIST-1d or LHS 1140.b, Ross 128b holds a unique position. It is close enough to Earth for detailed study, while also orbiting a star that provides relatively mild conditions. The study of Ross 128b is part of a much larger effort to identify potentially habitable worlds beyond our solar system. Over the past few decades, missions like Kepler and TESS, Transiting Exoplanet Survey Satellite, have revolutionized our understanding of exoplanets, revealing that planets are not just common in the galaxy, but incredibly diverse. Kepler alone discovered thousands of exoplanets, many of which are in their stars' habitable zones. TESS has continued this search, focusing on nearby stars that will be prime candidates for atmospheric analysis in the coming years. Future missions, including the European Space Agency's Plato mission and NASA's planned Habitable Worlds Observatory, will build upon this foundation, helping to determine how many Earth-like planets truly exist. Ross 128b is a reminder of how much we have yet to learn. It is one of the closest known exoplanets with the potential for habitability, but it is likely just one of many waiting to be discovered. As technology advances, we may soon reach a point where we can not only study these distant worlds, but perhaps even confirm whether life exists beyond Earth. The search is still in its early stages, but planets like Ross 128b are bringing us closer to answering one of humanity's most profound questions. Are we alone? Ross 128b represents one of the most exciting discoveries in the search for habitable exoplanets. With its Earth-like size, potential for liquid water, and relatively calm red dwarf star, it stands out as a prime candidate for further study. Advanced telescopes like the Extremely Large Telescope, ELT, and the James Webb Space Telescope, JWST, will soon provide more insight into its atmosphere, possibly revealing whether conditions there could support life. Meanwhile, SETI researchers continue listening for any signals that might suggest an intelligent presence, keeping Ross 128b in the spotlight as one of the most intriguing nearby worlds. The search for life beyond Earth is entering a new era, one where planets like Ross 128b are no longer just distant dots in the sky, but real places that we can study in detail. Each new discovery brings us closer to answering one of the most profound questions of all time. Are we alone in the universe? If Ross 128b turns out to have an atmosphere, or even the faintest hint of biological activity, it could change our understanding of life's place in the cosmos forever. Is Ross 128b truly habitable? Only time and further research will tell. But one thing is certain. The discovery of this nearby exoplanet has brought us one step closer to finding out whether life exists beyond Earth. What do you think? Could Ross 128b be the world where we finally find evidence of extraterrestrial life? Share your thoughts in the comments, and don't forget to follow for more updates on the search for habitable exoplanets.